Hello everybody. Today we are going to perform the electrolysis of acidated water. Electrolysis is a chemical process which allows us to split an element into its constituting ions. Here we have 5 batteries in series. I have connected 2 electrodes made of lead, which is an inert conductive material, to them. Let us measure the voltage of these LEDs. Batteries. As we can see, the voltage of these 5 batteries equates to roughly 38.8 volts. To perform electrolysis, we will simply put both of these leads into water. We will then bring a burning splinter to the negative electrode and see if it does pop 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 sounds, very much similar to a fool jhadi. This will confirm the presence of hydrogen gas on the negative terminal and oxygen gas on the positive terminal. Let us now put the electrodes in. But before that, let us first see how the project itself works. As you can see, we have H2O in a can or jar or container, anything, and we have a circuit which is completed by the H2O. We have the anode, which is the positive end, and the cathode, which is the negative end. Now, we know on the periodic table that the elements usually with a positive charge are found towards the left side of the periodic table, and those with negative charge are found towards the right side of the periodic table. Now, since oxygen is found towards the right side of the periodic table, it must have a negative charge. But since it has a negative charge and opposite charges attract, it is found towards the positive anode. Hence, the bubbles of oxygen formed will be towards the positive anode, O minus, and hence the positive hydrogen ions, H plus, will be at the cathode. Now, why do they separate? It is because the force bonding them is overpowered by these two charges. And since opposite charges attract, much like a magnet, a strong magnet, like tearing apart a bond, these are two strong charges tearing apart the water bonds, changing them into oxygen and hydrogen. Now, to test for the presence of hydrogen gas, as I mentioned, we use a burning splinter, and that burning splinter must produce pop pop sounds much like a fool chhadi. So, if we bring a matchstick to the H plus side, and because the bubbles are here, that's right, but they must also be above. We just can't see them. So, if we bring a burning splinter over there, we must hear pop, pop, and once we take it away, it should quiet down. Bring it back, take it away, quiet down. Now, back to the experiment. We are now putting the electrodes in water. Careful not to short circuit them. As you can see, small bubbles are forming over both the anode and the cathode. The cloudy texture of the water is due to the presence of citric acid from the lemon. Let us now test for the presence of both hydrogen and oxygen, respectively. We have taken a burning match When near the hydrogen gas, popping sounds could be heard. When the matchstick was moved away, the popping sounds stopped. Let's see that again. Thank you. Why are you still here? Bye bye.